zero quantities and negative quantities. In analyzing the problem of infinity and infinite quantities, we touch upon several other problems, the elucidation of which is equally necessary for a right understanding of a new model of the universe. Some of these problems have already been examined, however there remain the problems of zero quantities, and of negative quantities. Let's try to begin the examination of these quantities in the same way that we began the examination of infinity and infinite quantities. By trying to compare their meanings in mathematics, in geometry and in physics. Zero in mathematics always has one meaning, and there is no reason to speak of zero quantities in mathematics. Zero in mathematics and a point in geometry have approximately the same meaning, with the difference being that the point in geometry indicates the place at which something begins, or at which something ends. A point at which something happens, for example where two lines intersect one another. Whereas in mathematics, zero indicates the limit of certain possible operations. But in their essence, there is no difference between zero and the point, because neither has independent existence. The case is quite different in physics, however. The material point is a point only on the given scale. If the scale is changed, the point can prove to be a very complex and many-dimensional system of immense measurements. Let's imagine, by way of illustration, a small satellite photo on which even the biggest towns are points. Then zoom in and bring out the context of these points, or fill them with content as is done with close-up photography. Then what looked like a point will manifest a great many new properties and characteristics, along with all the extensions and measurements included in it. In the town will appear streets, parks, houses, people, and if the resolution is good enough, maybe even an empty carton on the sidewalk. How are the measurements of these streets, squares, and people to be understood? When the town was for us a point, viewed from the satellite, they were smaller than a point. Is it not then possible to call them negative dimensions? The uninitiated, in the majority of cases, do not know that the concept negative quantity has no definition in mathematics. It has a certain meaning only in elementary arithmetic, and also in algebraical formulae, where it designates the operation to be performed, rather than the difference in the properties of the quantities. In physics, negative quantity does not mean anything at all, nevertheless we have already come upon negative quantities. It was when speaking of dimensions inside the atom. Then it was pointed out that although the atom, or the molecule, has no dimension for the direct senses, i.e. it is equal to zero, those dimensions or extensions inside the atom are still smaller, i.e. smaller than zero. Therefore we need no metaphors or analogies in order to speak about negative dimensions. These are the dimensions within what appears to be a material point. Which explains why it is wrong to regard small particles of matter, such as atoms or electrons, as material. They are not material because they are negative physically, i.e. smaller than physical zero. Putting together all that has been said so far, we see that aside from the period of 6 dimensions, we have imaginary dimensions, the 7th, the 8th and so on, which proceed in non-existent directions, and differ in their degree of impossibility. Then negative dimensions within the smallest particles, representing for us material points. In new physics, the conflict between the old and new ideas of time and space are particularly marked in concepts regarding a ray of light. However, at the same time, a right understanding of the ray of light will resolve all points at issue on the question of time and space. To complete the new model of the universe, therefore, it is necessary to analyze a ray of light. However, before beginning this analysis, we need to examine certain further properties of time, taken as a three-dimensional continuum. Until now we have examined time simply as the measure of motion. However, motion in itself is the sensation of an incomplete perception of the space in question. For a dog, for a horse, for a cat, our third dimension is motion. For us, motion begins in the fourth dimension, and is a partial sensation of the fourth dimension. But as for animals, the imaginary movement of objects that in reality constitute their third dimension, merge into those movements that are movements for us, that is, into the fourth dimension. So for us, movements of the fourth dimension merge into movements of the fifth and sixth dimensions. Starting from this, we must endeavor to establish something that will allow us to judge the properties of the fifth and sixth dimensions. their relation to the fourth dimension must be analogous to the relation of the fourth dimension to the third, of the third to the second, and so on. Which means that first of all the higher dimension, must be incommensurable with the lower dimension and form infinity for it, seeming to repeat its characteristics an infinite number of times. Therefore, if we take time, that is extension from before to after, as the fourth dimension, then what will be the fifth dimension in this case? That is, what forms infinity for time, and what is incommensurable with time. It is through phenomena of light that we are able to come into immediate contact with movements of the fifth and sixth dimensions. The line of the fourth dimension is always and everywhere a closed curve or cycle, although on the scale of our three-dimensional perception, we do not see either that this line is curved, or that it is closed. This closed curve of the fourth dimension, or the circle of time, is the life or existence of every separate object, for every separate system that is examined in time. But the circle of time does not break up or disappear. It continues to exist, and joining other previously formed circles, it passes into eternity. Eternity is the infinite repetition of the completed circle of life, an infinite repetition of existence. Eternity is therefore infinity for time. Quanta for light are precisely such circles of eternity. The third dimension of time, the sixth dimension of space, is the stretching out of those eternal circles into a spiral or a cylinder with a screw thread, in which each circle is locked in itself, and motion along it is eternal. Simultaneously passing into another circle, which is then also eternal, and so on. This hollow cylinder with two kinds of thread would be a model of a ray of light, a model of three-dimensional time. The next question is, where is the electron? What happens to the electron of the luminous molecule which sends out quanta of light? This is one of the most difficult questions for new physics. From the point of view of the new model of the universe, the answer is clear. The electron is transformed into quanta, it becomes a ray of light. The point is transformed into a line, into a spiral, and into a hollow cylinder. As three-dimensional bodies, electrons do not exist for us. The fourth dimension of electrons, that is their existence, the completed circle, also has no measurement for us. It is too small, has too short a duration, and is shorter than our thought. We cannot know about them, i.e. we cannot perceive them in a direct way. Only the fifth and sixth dimensions of electrons have certain measurements in our space-time. The fifth dimension constitutes the thickness of the ray, and the sixth dimension is its length. Therefore in radiant energy we deal not with electrons themselves, but with their time dimensions. With the traces of their movement and existence, of which the primary web of any matter is woven. Now if we accept the approximate description of a ray of light as a hollow cylinder consisting of quanta lying close to one another lengthwise along the ray, the picture becomes clearer. Firstly, the conflict between the theory of undulatory movements and the emissions theory is settled. It is settled in the sense that both theories prove to be equally true and equally necessary, although they refer to different phenomena, or to different sides of the same phenomena. Vibrations or undulatory movements that were taken for the cause of light, are undulatory movements transmitted along already existing rays of light. What is called the velocity of light, is probably the velocity of these vibrations passing along the ray. This explains why the calculations made on the basis of the theory of vibrations proved to be correct, and made new discoveries possible. In itself a ray has no velocity at all because it is a line, a space concept and not a time concept. No ether or dark matter is necessary, for vibrations travel by light itself. At the same time light has atomic structure, for a cross-section of a beam of light will show a network through the mesh of which, the molecules of the gas it meets can easily slip. In spite of the fact that science speaks of the very accurate methods that are available to count electrons and measure their velocity, it is permissible to have doubts about whether they really mean electrons, and not their extensions along the sixth dimension. The extensions of which have already acquired space meaning for us. The material structure of a ray of light also explains its possible deviation under the influence of forces acting upon it. However, it is certain that these forces are not attraction in the Newtonian sense, although they may quite possibly be magnetic attraction. There remains one last question, left untouched until now. That is the question of the duration of the existence of small particles, molecules, atoms, and electrons. The question has never received serious consideration in physics. Small units are regarded as constant, like matter and energy, that is, as existing for an indefinitely long period of time. If there was ever any doubt about this, it has never left noticeable trace, and physicists speak of molecules, atoms, and electrons first as particles of matter, and second as particles that exist parallel with ourselves, occupying a certain time within our time. This is never said directly, but on this point doubt does not arise. Yet in reality the existence of small units of matter is so short, that it is impossible to speak of them in the same language as that in which we speak of physical bodies, when they are the subjects of examination. It was made clear before that the space of small units is proportional to their size, and in exactly the same way their time is proportionate to their size. This means that their time, i.e. the time of their existence, is almost non-existent in comparison with our time. Physics speaks of observing electrons and calculating their weight, velocity, etc. But an electron is for us only a phenomenon, and a phenomenon that is quicker than anything visible to our eyes. An atom as a whole is perhaps only a longer phenomenon, but longer on the same scale, just as there are various speeds in a video camera. But both the atom and the electron are only time phenomena for us, and furthermore instantaneous phenomena. They are not bodies or objects. Scientists affirm that they have seen molecules with the aid of an electron microscope. However, do they know how long by their clock a molecule can exist? During its very short existence, a molecule of gas, which alone may be accessible to observation, travels through immense distances and will in no circumstance appear either to our eye, or to the photographic lens as a moving point. Seen as a line, it would inevitably intersect other lines, so that it would be more than difficult to trace a single molecule, even for the period of a small fraction of a second. All this must be kept in mind when speaking, for instance, of phenomena of light. A great many misunderstandings fall away if we bear in mind the fact that an electron exists for an immeasurably small part of a second, which means that it can never under any condition be seen or measured by us as we are. It is difficult with existing scientific material to find firm ground for any theory as to the short existence of small units of matter. The material for such a theory is to be found in the idea of different time in different cosmoses, that forms part of a special doctrine on the world that will be examined later.